Hey everybody, welcome back to Faraday Research, and just doing this quick little video for everybody because one of my subscribers asked me for the actual schematic of how I'm doing my generator. So I'll try to explain it as easy as I can. Let's start over on this side where we start. The start of the circuit. So you got your battery, and then you're going to want to get a high voltage spark generator. It could be an ionizer. It could be anything that generates consistent high voltage. Mine can produce 11 kVA at 12 volts. All right, so that's perfect for a battery. You can hook that up to a motor controller, and you can vary the actual amount of voltage that's going into the system. I hook mine up to a power supply so I can really watch how much is being drawn from this high voltage generator, because you'll find you're going to get spikes where the amperage might get drawn up, and if it goes too high you can burn out your high voltage module. So you can get that on Amazon. They're like 25 bucks. Anyways, okay, so you hook up the battery to your high voltage generator, then you're going to have two wires coming off. One's going to be positive and negative. All right, so you're going to put in parallel between the positive and negative two 15 kVA ceramic capacitors. Now you can toy around with the different values and sizes. These ones that I'm using are 20,000 picofarad at 15 kVA. So it kind of, this is going to generate a high voltage even higher. It kind of works on the basis like the Marx generator. So something very similar to that. So you want to get at least two of those in there. With this one, two 15 kVA ceramic capacitors work just fine. So after that, we're going to follow the positive lead to the two spark gaps. Now these are in series, not parallel, they're in series. So you got positive going right through the two spark gaps. You can even experiment with three or one or whatever you wish, but they have to be in series. So now we're moving along to the coil. Now the coil is very easy to make. Well, it's not easy, but it's a very simple principle. It basically runs kind of like similar to a jewel ringer. So it's like a bifilar. So the very first layer is going to be your small wire. It's going to be 26 gauge to 30 gauge, depending on how many turns you want to do. So, but I do suggest anywhere from 600 to 1,000, maybe even more than 1,000. It all depends how big of a field you want to create. So with the 26 gauge wire, let's assume that we're using 26 gauge, you wrap that right across, and then after you're done, cut it off. Don't cut it off, just, or you'll probably have to cut off a section, but leave a good portion, probably like 4 or 5 inches off the end. So you wrap it tightly, make sure there's no kinks, no spaces, no nothing in between it. Then after that's done, you got to put the secondary winding. Now this is a thicker gauge wire, so you're going to go to a 18 to 20 gauge wire. I use speaker wire for mine. And with that one, you're going to do the same thing, wrap it right across. You can do 600, 1,000, whatever fits, basically to cover the entire coil. Now, if you're wrapping the small wire in clockwise, this other wire, the bigger wire, the 20 gauge or the 18 gauge, you might want to experiment wrapping it the opposite direction, counterclockwise around in the opposite direction. So after you wrap that, tie it off or tape it off or whatever, however you're going to seal it, glue it, whatever you want to do, you're going to have the two wires coming off the ends. Now these two wires off the ends are your high voltage AC. So now you're at the point where you can now start to manipulate it in whatever way you want to do it. So either you hook it up directly to a load, like say like a light bulb or LED light or whatever you want to do, you can do that. Or if you want to change it into a DC source to charge capacitors or batteries or whatever, and change it with a full wave bridge rectifier, I would suggest starting with a minimum of 40 amp Need something pretty beefy, otherwise, even though it's high voltage, you don't know the kind of amperage you're going to get out of it, so I would go with something a little higher rated. I think the one I'm using is like 40 amp capability, so that's pretty safe. I haven't blown it up yet, so you can start with that, and then from there you go to your DC source. It could be capacitors, it could be batteries, it could be a DC motor, it could be whatever you want. So that's it. That's pretty much it. It's a very simple circuit to do. So just let you try to take a screenshot of that. And yeah, and experiment. You just have to experiment with the different wire sizes, the length of the coil. You might even want to shove a ferrite rod inside, which I'm going to be trying to do. Well, I don't have ferrite rod. I'm going to try a steel screw, spool or screw. I think I got one that's pretty long that I can test that and see what kind of reaction I get. So yeah, from there you can just start experimenting and see what works and what doesn't. I've even tried 3 spark gaps in series, and that seems to really pump out a lot of power too. So anyways, yeah, this video was made for Jesse, one of the subscribers. So yeah, take a screenshot and get building. Give me a thumbs up if you like the video. Subscribe at the bottom right hand corner, and I also got the Patreon in the description and Bitcoin wallet if you want to donate, and we'll see everybody soon.